Pretty neat. All right. Could you give me a little cue idea of what it is that you do, Timothy? All right. Sounds like a useful thing. How did you come to be? Why were you made?
I was created for this lecture computer science course over a period of months using Java.
So, thank you very much. I guess we'll get back to you later after we've talked about how you were created. Also, before you go, though, who made you? Who are your creators?
My creators are Matthew, Bruce, Byron, and Ryan Schwartz.
All right, well, excellent. Okay, I guess now we'll get back to you later.
I'll see you then.
Okay, so clearly we had a lot of fun doing this, and what our purpose was, the task that we were charged with, was creating a talking head that would involve synchronized sounds, words, and their images, so that we would come up with an end product like this, where it actually looks like a head is talking to you. So what that involved in the title of computer science is we had to learn some fundamentals of linguistics, because it wouldn't simply be good to record the entire English language and then reassemble that. There would be no point to that. It would be costly and inefficient. So in order to learn the linguistics, and I guess explain it for us now, we'll turn it over to Matthew Veracruz.
Okay. Hello. All right. So basically, with the creating a text-to-speech, you have to actually type the speech, and you have to understand how is speech actually created, what goes into producing speech. And we discovered that there are things called phonemes, and they're basically the smallest unit of human vocalization that are distinguishable from one another, and you put these together in order to create words. And okay, so now that we understand that we have to use phonemes, our program had to recognize one phoneme for another. And there's this thing called the alphabet symbol set. And in alphabet, phonemes are represented by either one or two capital letters. And okay, and now that we have a way of representing the phonemes, now we need a way to associate with the word a particular group of phonemes. And we borrowed the Carnegie Mellon University dictionary, pronouncing dictionary, which has like 130,000 some odd entries of a word and its appropriate phoneme pronunciation. And okay, now it doesn't just end at phonemes. Now there are these things called allophones, and these are actually variations on a phoneme. Each phoneme can have multiple allophones, and that's determined by kind of like its position in the word and what comes before or after it. And the examples that we have for allophones are like in the words ring and rung. And we can bring up the word like their talking head to say the word ring and rung. And the
Ring.
Play it again.
Ring.
R-U-N-G. Ring, rung, okay. So you would think that the NG phoneme would be pronounced the same, but actually because of the phoneme that precedes it, there are different types of a sound. And in order to have it blend easily from the one phoneme to the other, you have to pronounce the NG just a little bit differently. So our program had to take that into account. And okay, so now we have allophones. We needed a way to represent the allophones, and it's basically very similar to how we decided to represent the phonemes, which is using these capital letters to stand in before an allophone. And our representation is based off of Steve Jett's symbolization of allophones. And so now that we have all of this stuff, now we just have to put it together into our program, the structure of it, and Byron Avila will take it from here.
Hello, everyone. Besides from the linguistics part of the project, we also had to talk get into, like computer science a little bit. In order to develop a text-to-speech simulation, we kind of had to establish a structure. This structure has two main parts. The beginning of the structure, you start with a user input, and the final result, as you saw, is the talking head with a speech. On those two, so in those two stages, what we did is take the user input. As we saw, we have a text field. We grab that text input and we break it into independent words. As you can see in the sample there, projects are done, finally. We grab projects independently and we do a dictionary lookup. So we have as Matthew mentioned before, we have about 125,000 words in a dictionary, and each of those entries has a phoneme collection or a phoneme set which represents that word. So if you see that's an example of Goldman on the dictionary. So there's plenty of words on that dictionary, and as we grab one word, what we do is now we have these sets of, we have those phonemes. Now the next stage on the assembly line was to grab or associate an image with each of the phonemes. If we, what we need in order to do that, we have a file that has each of the images with an associated number. That number represents the name on a collection set of files. Of pictures, I'm sorry. So those pictures, those are JPEGs, regular pictures, and they have Matthew's face on it, and they have a name and a number with it, and those are going to be linked now with the phonemes. Then after that, now we have a phoneme, and we have a picture associated with it. We go to the next step, which is to determine the allophone. As Matthew mentioned, there's a lot of different variations of an allophone, of a phoneme, I'm sorry. And as you can see, the AA could become two different options. So there's a set of rules that allow us to choose based on the position or the location or the previous and next phonemes, what is the correct allophone. Okay, now we have an allophone. With the allophone, what we wanted to do is associate a specific sound. We, on our WAV file, on the sound file that we have in memory, we have recorded all the allophones that we have. We have 72 allophones, and each one of them has
A, E, I, O,
As you can see, that was just it's one single file, and once we do a lookup on the text file, we grab the first input, which is the position on that file, and we also grab its length. With that, we could extract from that big WAV file the specific location where we want to use that to associate with the allophone. After that, we have all the pieces pretty much to create a spoken word. And the spoken word is created. It has the image from a phoneme. It has the sound from an allophone, and it also has the word itself, right? So we chose project. So project it's being carried along, and we use that so you can see in the bottom of the image what word is actually being pronounced. Now that we have those spoken words, we find them up, and those are going to be synchronized with the sounds. We're going to collect all the data that we need to. So we have all the data for the sound, the images, and the words. So we combine them, and we synchronize them so that they could play simultaneously. And then we have the talking head. After this point, we pretty much we're gonna talk about the virtues and the applications of the project, and we're gonna leave you with Ryan.
Right. So as we saw, we were able to accomplish that. We were able to get images to come up on the screen while a phoneme was being pronounced as a particular allophone. So we got that. So, but it was kind of a discussion. Well, okay, so we got the linguistic science down. We got the computer science down. It obviously runs, and it runs in some neat ways that we can't discuss. But what we want to do is, well, there has to be something. I mean, if we ship this to market with Matthew's voice and pictures, well, as fond as I am of him, that's not really going to be so great. There are uses where we want women and other various things. So what we wanted to point out, and what I guess I just asked Timothy directly, is what makes him so great?
I am easily extendable and customizable.
Okay, so easily expanded and customizable. What do you mean by that?
My text files can be modified and my images can be replaced without having to recompile the code.
Okay, so interesting. That's the point that I want to harp at, is we wrote this in Java, and in order to get it to run, you have to compile it. But the stuff that we're getting, our dictionary, the pictures that we're doing, and that sound file that was being addressed multiple times before, that's not all part of the compiled code. We can change that at any point without having to go through that technical stuff. So, you know, if there are like words that we don't want to say, you know, can you say the word editable, which I don't think is technically an English word, but we use it anyway.
No, I can't.
Okay, so let's rectify that. You can see we saved ourselves a little bit of trouble. There's that editable word along with its following phonemes. So you can see we added very crude, so that could be said in the beginning. So again, those are our phonemes that we're going to do. So when we reboot it, and that's again all that you need to do, change some files, reopen the application, and now editable as a word will be able to be used. So when he's getting over shyness, I'll ask him, you know, how about now? And say editable.
And I can now say editable.
So, even polite. So not only that, so, you know, it would be a little too comprehensive to record all the allophones and get all the associated positioning in that, because that was fairly intensive. But we were thinking, you know, what is it good for? I mean, you know, grade is nice, but what we want to do is, you know, who would buy it? Who was thinking? So I, you know, was having some fun and thinking about it. And it was like, well, you know, I guess I've been driving on the turnpike a lot lately, and I remember seeing those lit up signs that just say ice, you know, just, that's nothing. Or you have, you know, flashing lights and it makes you go on the, you know, AM radio station and, you know, hurt your ears with that static. So, you know, what if instead of that, we actually had some sort of big brother, you know, as talking head to us, you know, that let us know what was going on. Because, I mean, what's, you know, the worst thing about traffic is you don't know what happens during switch over. You see if it's a wreck or not. So let's imagine our talking head Timothy, you know, narrating to us the events of some traffic.
Driver, please be patient. There was an accident near exit 4.
Okay, so that's one idea. What about like ATMs was the other thing? I mean, it's already got a screen. You know, how hard could it be to add our guy in there? And so it was like, okay, well, you know, you want to be in and out. But what about, you know, if you don't really check your balance? What if there was an automated talking head to like let you know, the status of your account? So.
New customer, your balance is below 0. I will be charged starting tomorrow.
Oh, you know, something helpful like that. The other idea I liked was amusement parks. You know, you kind of, it's that whole game of like, oh, you know, which ride has the shortest line, you know, it becomes an argument based on no real facts, but what if there was actually a talking head to give you that information?
There is currently no line at the Summerman Ride Enjoy.
Okay, so to again reiterate, the value of this and why I'm just, excited beyond belief about it is, well, if you were going to record, like video record someone doing this, well, you have to find an actress, you have to record her saying it, and in the case of the traffic thing, well, okay, so an accident happened right now. By the time you get an actress in and you record all this, the police will probably have come in and cleared it out. So you would need something that was quickly, that could respond quickly. So all we're doing is typing some text up in there. And for the respond function, it's just a preset thing of what you can ask it. So, if it's some crazy bizarre situation that, the owners of the turnpike didn't anticipate, there's a chicken overflow and they become like mutated and, I don't know, the superhuman proportions, we could reflect that within a minute. It would take someone at the console to just be like, all right, let's set it on a loop and let people know to hide whatever chicken's will be. So there's that. The images are all in their own subdirectories. The audio is all in its own subdirectory, and it can be so easily used and not in any way, shape, or form tied to Fantastic Matthew's voice or images. And yeah, so I believe that concludes all the technical and kind of fun information we wanted to share. So Timothy, thank you.
Thank you for your time. I look forward to earning you in the future.
You're going to see Ryan twice tonight. He was on 2 project teams. He was being punished. So this was the first of the 2 you'll see him on. So the questions are only going to go to the other 2 gentlemen this time, and we'll get him on the next round. Matthew, can you tell me about stack? When we use one and what stack is in the data structures?
Okay, stacks are a data structure in which they employ the storage policy of last in, first out. You can think of them as like a stack of dishes. The first one you put on will be near the bottom. The last one you put on will be the first one that you take off. So certain implementations we can have for like stacks, or be like if you want to in code, you need to be careful of like the parentheses. You have to make sure for every open parentheses there's a closed parentheses. So in that case, you use a stack where every time it encounters an open parentheses, it increments something each time, and then every time it encounters a closed parentheses, it decrements, so that if it's all balanced out, you would be left with 0. And if you left with anything other than that, means you know that there's an inconsistency. There's some that don't have their pairs. And they have like the operations like pop, peek. Like pop removes the top element and returns it. Peek just returns it without removing it. You can push elements on top of the stack. And it's basically stacks.
Okay, Byron, tell me about hash maps.
Hash maps is a data structure that allows to identify certain keys. Think of it as a book, phone book, where each of the names represents a key, and what we have connected to that key is like a phone number, right? So in order to have a unique ID, we have to somehow generate that key. And we use an algorithm, usually like hash algorithm, in order to create those unique keys in order to obtain the unique information. Hash maps, there's usually a tendency, there could be collisions because, the algorithms could not always be strong, but a good hash map should be able to recognize that there's being a duplicate, and being able to identify those duplicates, either substituting it with a new one or just creating another one.
Okay.